Hello students, today we are going to discuss this question paper. This has been sent from abroad student. Let me solve this question. Actually, look at this. These are all from very basic organic chemistry portions. I think JEE and NEET people can easily do this one. But if you don't know anything about organic chemistry, then I will tell you how to solve these questions. Organic reactions, if you need the basic organic reactions, or if you are having so many confusions about that organic reactions mean, you can listen this video completely. It will be helpful for you, and this will be very basic only. I will not teach you the more mechanism based question and everything. So don't worry. This is not a mechanism based question, but even though if it is a mechanism based question, that will be very very easy if you are learn if you are doing by this method. I will do that is I will give you a shortcut for you that will be very easy to solve any organic reactions. First of all organic reactions are from some basic mechanisms. So only there are 7 types of reactions in organic chemistry. That 7 types of reactions only we are doing again and again for every compound. And in that case also, one type of organic compound will give one type of reaction. First of all, I'm going to give you which type of organic compounds will give which type of reactions. That will be helpful for you. First of all, we are having so many organic compounds. So I'm going to start with hydrocarbon, alkane. Look at this alkane. So in alkane, only one typical organic reaction will happen. That is called free radical mechanism. Free radical substitution. It's not free radical mechanism, free radical substitution. Only one type of reaction will happen in alkane. Free radical substitution. I think you know about alkane. Alkane means there should not be any functional group. Only carbon and hydrogen will be there. There will not be any double bond, triple bond. There will be only single bond, carbon, hydrogen. So the best example may be ethane, propane, butane, like that. So free radical substitution only will happen. I will give an example for free radical substitution. So to give the free radical substitution, we have to give the reagent. That reagent should produce free radical. For example, if you are having ethane, CH3CH3. So this is alkane, and if you want to give the free radical substitution, you have to add the reagent Cl2 and you have to pass the light. This reagent will produce Cl dot free radical. So this Cl dot will replace one of the hydrogen in ethane. So look at this, that Cl dot is replacing one of the hydrogen in ethane. So there will be 2 Cl dot. So you can refer the reaction, right? You can give the reaction like this. This is very basic actually. So many interpretation will be there. But first please learn that basic thing. Then it will be easy to have that difficult things in the free radical substitution. But this is enough for to solve these questions. Actually, this is a board question. So you can solve this question easily by knowing that basic reactions are known. So the basic reactions, that is in alkane, free radical substitution will be there. In that free radical substitution, you should give the free radical producing reagent with the substrate. Usually this is called substrate. Remember here, substrate. And our alkane is a substrate, and then we are giving one reagent. That reagent is producing free radical. Free radical means the free radical will be formed from homolytic cleavage. I think you know about that, but I am going to teach in this video about the basic organic reactions only. So here Cl dot has been produced, H dot has been released, and then that H dot has been substituted by Cl dot. That's why we are saying this as a free radical substitution. So then you can ask, ma'am, is there only chlorine free radicals? No, we can produce the bromine free radical also. Is there only passing light we can able to produce the free radical? No, we can give H2O2 also. We can give some benzoyl peroxide also. So many reagents are there. So based on that free radical producing reagents, so you can have the 3 reagents. That is enough. That is H2O2, passing light, and then you can add benzoyl peroxide, C6H5, C double bond O, O, C double bond O, C6H5. Actually, it is not necessary to memorize this one for the board exam. If they are giving that reagent, then you can easily identify, yes, there will be a production of Cl dot, and that Cl dot will replace that hydrogen present in the alkane. And then here also Br dot will be produced. That Br dot will replace the hydrogen present in the alkane. So alkane, we can have only the free radical substitution. And alkene, it's very easy. Alkene, there will be only addition reaction. C double bond C will be there. There will be only addition reaction. So addition reaction alone will be there in the case of alkene. Not only in alkene, alkyne also. In alkyne also, there will be a addition mechanism. That is, addition reactions alone will be there. So here, look at this. Whenever you are having double bond, either you can add bromine in CCl4. When you are adding bromine in CCl4, then there will be the addition of bromine at the double bonded center. So here, look at this, one bond will be broken and then we will get to C, single bond C, bromine will be added here. That's it. Just you have to break one bond and you have to add. That is called addition. And then here, if you are having C triple bond C compound, then there will be, again, if you are adding these reagents, then you will get that only one bond will be there, two bromine atoms will be added instead of that two bonds. This is called addition reaction. The reagents used for that addition reaction, so many reagents will be there. I will tell you the reagents. Br2CCl4 is one of the reagent, and then even Cl2CCl4 will give Cl addition. And then you please write everything. That I think it will take some two sides of A4 sheet. That is enough to answer all the organic reactions. So don't worry about that. Just write all the reagents that can give which reactive species. Here the Cl will be produced and Cl will be added at the double bonded center or triple bonded center. And then you can add hydrogen also. Hydrogen in the presence of platinum. Hydrogen in the presence of tin. Hydrogen in the presence of nickel, like that, any metal. And then even you can add HOH. That is, H and OH can be added. Now you can ask, ma'am, in here Cl is there, Br is there, HH is there, but here HOH means one will be negative part, one will be positive part. Then how can I add that? Like that you can ask. So if you are giving H plus, then the negative part of the adenine adds to the carbon containing less number of hydrogen atom. So this is called Markovnikov addition. Based on Markovnikov addition, this reaction will happen. So don't worry. If it is necessary for the question discussion, I will explain on that part. But in this video, it will take more time, right? That's why I'm not explaining here. This is called Markovnikov addition. To have that anti-Markovnikov addition, that same H2O in the presence of B2H6, we will have anti-Markovnikov addition. Markovnikov and anti-Markovnikov addition. Both are addition reactions. And then you can add even HBr also. HBr, again H plus. This is also Markovnikov addition. And then HBr and H2O2. This is actually anti-Markovnikov addition. That's it. So addition reaction, so many addition reactions are possible. The Bayes reagent, and look at this Bayes reagent, KMNO4, 0 degree, and alkaline. If the medium is alkaline, then you can add OH at the two parts. OH will be added at the double bonded parts. Okay. And then alkene, alkyne, both we have seen, and aldehydes and ketones. Aldehydes and ketones. In aldehydes and ketones, there will be only nucleophilic addition. Here also addition, but the nucleophilic addition will be happen. Nucleophilic addition. So nucleophile means the species which is having negative charge. That is, it will be attracted by the nucleus. That's why we are saying that as a nucleophile. And then if you are having the aldehyde or ketone group, there will be a carbonyl group. Always in that carbonyl group, del plus charge will be there. In oxygen, there will be a del minus charge will be there. So whenever you are giving nucleophile, so definitely some electrophile will also be there in the solution, because minus charge could not be alone in that solution, right? So are in that reagent, for example, if you are adding H plus and Cn minus, Cn minus is a nucleophile, H plus is a electrophile, then how the reaction will happen? Look at this. C, the bond will be converted into single bond. O is having minus charge, it will attract that H, and then C is having positive charge, it will attract that Cn. Now we are having nucleophilic addition reaction, addition product. So look at this, in aldehyde ketone, this is the only kind of reaction. You have to select positive and negative part, and you have to add based on that O and carbon, right? Negative part will be the nucleophile. And then the next case, alkyl halide. Look at this, alkyl halide and alkyl alcohol. Both will give same typical reactions. One is nucleophilic substitution. One is nucleophilic substitution. So in that nucleophilic substitution, we have to give the reagent that should produce the nucleophile. For example, if you are having alkyl halide, for example, CH3Cl, this is called alkyl halide. When you are reacting this one, you have to, that is, if you want to carry out nucleophilic substitution, you have to produce nucleophile. Nucleophile means the species which is having negative charge. So negative charged nucleophile you should give. So like that reagent, you should add. So if you are adding PCl5, Cl minus will be produced. But actually already Cl is there, right? So I'm going to give some other nucleophile. That is, I'm going to give aqueous KOH. Be careful here. Aqueous KOH will produce OH minus nucleophile. And then here what will happen? Cl will be replaced by OH. So Cl will be substituted by OH. That's why we can call this as a nucleophilic substitution. So there will be two kind of mechanisms, but don't worry. First we will see the simple mechanisms and then we will go further. And then here nucleophilic substitution for whatever may be. If you are having alcohol, then if you are adding PCl5, that PCl5 reagent will produce so many Cl minus. That Cl minus will substitute that OH. So you can give the nucleophile by the reagent. Then the substrate automatically will give the substituted product. So that is called nucleophilic substitution. Another kind of reaction will also be there. That is called beta elimination. In that beta elimination case, reactions, you are not necessary to bother about that. Here, in nucleophilic substitution, so many reagents are there to produce the nucleophile. For example, if you have added PCl5, Cl minus will be produced. AgNO2 means then NO2 minus nucleophile will be produced. And KNO2, if you are adding KNO2, then ONO minus nucleophiles will be produced. And then if you are adding aqueous NaOH, then OH minus nucleophile will be produced. So many kind of nucleophilic substitution is possible. That is, so many products are possible. So many reagents are possible for the nucleophilic substitution. But beta elimination, in the case of alkyl halide, look at this. In the case of alkyl halide, why I have taken that 2 carbon alkyl halide? Because the alkyl halide only is having beta position. This is alpha, this is beta position. This hydrogen and this Cl will be eliminated by the addition of alcoholic base. Alcoholic base. I think you know about the active species here. Alcoholic base means alcoholic NaOH or alcoholic KOH. Anything you can add. So if you have added this one, this H and Cl will be eliminated. Then CH2 will be there. CH2. There will be a double bond in that between alpha and beta carbon. Remember here, you should add alcoholic KOH. This should not be an aqueous KOH or aqueous NaOH. Here look at this. If you are adding alcoholic KOH also, you will get that beta elimination in the case of alkyl halide. H and Cl. Alpha carbon will give Cl and beta carbon will give H. So you can have the reaction like this. If you want to carry out that same beta elimination in that alcohol, then you have to give another one reagent, CH3, CH2OH. Then the reagent used for that HOH removal, that is called beta elimination. OH from the alpha carbon, H from the beta carbon. That is called beta elimination. To have this reaction, you can add Al2O3 or P2O5 or concentrated H2SO4, anything you can add. So these are all having limited reagents only, so not necessary to bother about this beta elimination more. But you should remember this one, this is very very important. Whenever you are adding alcoholic AOH or alcoholic NaOH, then there will be the beta elimination. Remember that always. For NEET I will explain that reactions again, so don't worry. Every particular reactions I will explain with the that is active species, mechanisms, and everything I will explain for NEET and JE. But this is for board, that's why I'm explaining like this. And here look at the CH2 double bond CH2. Okay, so we have given so many reactions, and then finally I'm going to give one more reaction is there, but it is not there in our 11th. First you please learn this mechanisms, then automatically that will be easy for you. That is for amines case as well as carboxylic acid ester, and every case that will be very very easy. First you please learn these basic reactions, then you can there should not be there will not be any fear about that organic chemistry if you have learned that one. That's why. Okay, then the next thing, here we are going to take the organic compounds, whatever may be the sorry aromatic compounds, whatever may be the aromatic compound. Either it may be benzene, or either it may be phenol, either it may be amine, either it may be carboxylic acid, either it may be COOH. So the one kind of CHO aldehyde, any kind of substituent is whatever may be the kind of substituent. If you are giving electrophile producing reagents, electrophile producing reagents means just if you are adding Cl2, what will happen? That AlCl3 catalyst will take that negative part alone, so the positive electrophile will be produced. So here, when there is a positive electrophile production reagents, then there will be a electrophilic substitution. Always benzene ring will give electrophilic substitution. Here, there is no substituent. So any hydrogen can be removed. And here, for OH, if you are adding that same reagent, if you are having that phenol, if you are adding that same reagent, phenol will give para substituent more. I will explain that why. Here it will give para substituent, and then NH2 will also give para substituent. Here there will be some restriction that I will teach you in the amines based lesson. And then here carboxylic acid is a meta directing. I will tell you where the meta directing will be there, where the para position substitution electrophile will be there, substitution will be there. I will tell you about that. So the name of that mechanism, this is also meta. The name of this mechanism will be electrophilic substitution. Whenever the aromatic compound, you can expect the electrophilic substitution. And don't worry, here always the catalyst will be there. So from that catalyst itself, you can easily think like that. Oh, that will be electrophilic substitution, like that. You can think. So electrophilic substitution. Hope it is clear. But anyway, we will work out based on that part. Students, all of you, please write all these things. Refer this video. Write all these things in the paper. Not necessary to memorize. Please have that paper in front of you, and then refer this paper and try to answer the question. Automatically everything will be memorized. It is just a 50%. That is 50. It's not a 50%. It's very basic. More than that, it is for board exam. More than that, if you want to learn, first you should learn this one. Then more than that, we can easily learn. It will be that will be so enthusiastic after that, after learning this basic things. Okay, let me solve that questions. I'm going to solve that one. Students, all of you, please write that, because based on that only we are going to work out that questions. Ready? Yeah, here look at this. They have taken one, wait a moment, I will take one thing. Yeah, actually they have taken one compound. That compound is alkyl alcohol. You can refer that one. So look at this. In alkyl alcohol, I think you have written that one. In alkyl alcohol, what are the main reactions will be there? Only two kind of reactions, either nucleophilic substitution or beta elimination, based on the reagent that we are giving. So here the reagent what we have given is SOCl2. It will produce the nucleophile. So there will be nucleophilic substitution as well as another one reaction. With what is that reaction? The another one reaction will be beta elimination, but we are not giving the reagent to give the beta elimination. That SOCl2 will give Cl minus. So there will be just replacement of OH, that is substitution of that OH by Cl. That's it. It's very easy, right? And then look at this. Here they have given that alcoholic NaOH. Look at this. Here again we are having alkyl halide. How I am saying that alkyl halide? This halide is substituted in that alkyl hydrocarbon part. That's why this is called alkyl halide. In that alkyl halide, they have added alcoholic NaOH. That is, ethanol means alcohol. Alcoholic NaOH means there will be beta elimination. Actually, alkyl halide, there are two reactions. One is nucleophilic substitution, another one is beta elimination. Here, we are going to give the beta elimination. But again, you will have a confusion. Look at this. Ma'am, this is alpha. We are having this is also beta, this is also beta. Two beta carbon atoms are there, but in your example there is only one beta carbon. Then where I have to take the H? Here I can take Cl, but where I have to take H? Here you should select the carbon which is having less number of hydrogen atom. So look at this. This carbon is having, this beta carbon atom is having 3 hydrogen atoms, and this beta carbon atom is having only 2. So less number of hydrogen atom should give less number of hydrogen atom containing carbon should lose hydrogen. That's why we have to remove that Cl and this H. That is called beta elimination. So beta elimination means actually HCl has been removed. Look at this. HCl has been removed, and then CH3 will be like this, and then CH will be there because we have removed that one HCl, H, and here Cl we have removed, here also one H, so CH3. This is actually the major product. The minor product also will be formed. Lesser amount of this beta carbon, that is here you can, this hydrogen can also be released, but this will be minor. So this hydrogen and this Cl will be removed, and in that case the double bond will be formed at the, look at this, CH2 will be there, CH double bond CH3. So here the double bond is at the first carbon, and here the double bond is at the second carbon. I have missed one thing, CH2. Because we have removed that H here, right? So CH2 will be there. And then look at this AlCl3. Whenever AlCl3 is there, you can easily confirm, yes, it is a electrophilic substitution. So electrophile should be produced. How the electrophile will be produced? That AlCl3 will take the negative part alone from our reagent. Then there will be a production of CH3, CH2 plus. That plus charge will be there at carbon atom, this carbon atom, because this carbon atom only loses Cl. So what it will do? It will, that is benzene ring, all the position will have a hydrogen atom. So what it will do? Just there will be a substitution of, instead of hydrogen, there will be a substitution of CH2, CH3. H will be removed as H plus. So H plus is substituted by this electrophile. That electrophile produced from CH3, CH2Cl, AlCl3. So this is the electrophilic substitution. Look at this. I told you, right? The electrophilic substitution will happen in the case of aromatic compounds. So here also, this is also aromatic compound. So here also electrophilic substitution will happen. Then you can ask, ma'am, you told me that AlCl3 only will give that electrophilic substitution, but here they have given some other reagents. Yes, this reagent will produce the super electrophile, that is NO2 plus. Look at this, NO2 plus electrophile will be formed. So I will tell you some compounds. If already one substitution is there, substituent is there in the benzene ring, then this substituent only determines whether the electrophile should be added at this position, that is ortho and para position, or meta position. So here in this benzene ring, these two are ortho, these two are meta, this is para according to this substituent. Actually, this NO2 plus is a formed electrophile. So the substituent will allow the NO2 at ortho and para position only. So the para position hydrogen will be removed as H plus, and NO2 plus, NO2 will be substituted here. And then F, yeah, the minor product also should be there, right? So ortho position due to steric hindrance, because this group is nearby, right? So ortho para, actually this group is ortho para directing. I will teach you which will be ortho group, which will be ortho para directing, which will be meta directing. I will teach you, don't worry. Ortho para directing. So this group is ortho para directing. That's why it is allowing the electrophile substitute at the para position major. In the ortho position, here look at this, there will be a steric hindrance, right? That's why somewhat minor product we will get when comparing that para product. A meta substituent will not be there, even it is formed where the amount will be very very less. And then look at this PBr3. Here again we are having alkyl alcohol. So look at this, alkyl alcohol will give beta elimination, or either it will give beta elimination or nucleophilic substitution. So here the PBr3 will produce Br minus. So what will happen here? That OH will be removed and then Br will be substituted. And then we will have the compound here. The compound will be, three molecules they are adding, right? So three molecules, if they are adding that one, then you will get that three, and then phosphorus will be removed, and then yeah, phosphorus will be removed. That's it. Everything will be finished. Everything has been finished here. Okay, refer this one for board exam. If you are having doubt, you please send the particular question, or if you need any particular interpretation about that mechanism, you please send it to my WhatsApp number, or to my mail. Thank you, students.